Okay. Good evening, everyone. I am here to talk about cryptocurrency and cryptocurrency security and adaptability. This is hopefully going to be not too technical and everybody can derive some benefit from the talk. I'm going to be talking about security in the context of consensus systems, which is a little different than you'd normally hear about in the context of security. Normally you hear about network security, data security, but in this case we're talking about consensus security. Who am I? I'm Jake Yocom-Piatt. I am the project lead for the Decred project, and I'm the CEO of Company Zero. The reason I'm here is that we have an enormous Brazilian community, and actually more traffic to our website comes from Brazil than from the United States. The topic I'm going to be talking about connects to Decred because Decred tries to do something different in terms of creating security for its consensus system. And that system warrants discussion, but I'm going to talk about it in the context of cryptocurrency more generally, and hopefully everybody can learn a little something about cryptocurrency in the process. What is Decred? We created Decred to address what we saw as a crisis of governance in Bitcoin, and that was the result of interacting with Bitcoin's central planning committee. We didn't feel that a decentralized network should be ruled by a central planning committee, so we figured we'd break that central planning committee up. What we've done is that we've taken the network and put the people who hold the coins in the network in charge of the network formally, which other projects have done to some extent, but we've gone a step further. The way the system works is that people hold coins, they take those coins, and then they opt into a governance system. And the way they do this is by locking their coins for a period of time, and then the coins are released after they've participated and voted in our governance system. I'm going to start talking about Bitcoin very generally so that people can understand how Bitcoin's consensus system fits into a bigger picture. Bitcoin can be described in literally a single phrase as gamification of timestamping. Why does gamification matter? Gamification matters because it allows us to remove oracles from the system. There's no need to have a single centralized person creating timestamps once you create a game to create those timestamps. So if you hear about miners or mining in the context of cryptocurrency, what's going on is that people are solving hard math problems and getting rewarded for it. And that's the game. It's a game. So it turns timestamping, where you group transactions into blocks, into a game. This is referred to as proof of work. Proof of work is one way to create a consensus system, and that's how Bitcoin operates. I won't get into the image on the left, but maybe you can read it yourself. How is Decred different from Bitcoin? It adds to this gamification process. Bitcoin gamifies timestamping, but Decred takes it a step further, and we gamify the decision-making process. By gamifying the decision-making process, we take the responsibility for making decisions out of a single person's hands, and that might include me if we were going the usual central planning committee route. What we do is we hybridize proof of work and proof of stake. You have to have both computer hardware for proof of work, and you have to have coins for proof of stake in order to make the system work. And as I said earlier, the system is opt-in. If you have the coins, you can show up and lock them. This system has worked out pretty well thus far, and at this point I'm going to make a little bit of a departure and start talking about consensus systems more generally in hopes of enlightening you. Consensus systems are how blockchains work. Blockchains only work because we all collectively agree to a set of rules. In this sense, it's very similar to religion. Religion doesn't really work if everybody's got a different version of the book they're reading from, and neither do cryptocurrencies. What is proof of work? Proof of work is one way to look at it, right, is gamifying timestamping. But another way to look at it is that it's a sortition on computational power. If you're familiar with the term sortition, you know what I'm talking about, but a sortition is a process that was actually pioneered by the ancient Greeks. And what they had done is, in order to run a government, rather than conduct an election, which is effectively a popularity contest, what they did is everyone who was eligible to manage to hold down a government job would put their name in a bucket. They would draw names from that bucket, and then people would be chosen to do jobs on a random basis for short periods of time. Proof of work does this on a rolling basis for timestamping. The other thing to think about here is that computational power is external to the system. Bitcoin and pure proof of work cryptocurrencies have a distributed system, and that distributed system requires people to bring computational power to the table, to put it on the table and demonstrate, I have this asset that I cannot fake. In a way, you could view this as meritocratic. That is, that you can show up, you could be a random nobody and show up with computational power, and then you're somebody in this system. Some examples of this are Bitcoin, Litecoin, and I included Monero because Monero differs a bit in the sense that it's intentionally ASIC resistant, which I'll get to a little bit later in the talk. And that's different from Bitcoin and Litecoin, which are ASIC mineable. Pure proof of stake. Proof of stake is a variation on proof of work where instead of expecting people to show up with computational power, we ask people to show up with coins. You go, okay, I have a distributed system, somehow coins get into people's hands, and then people start to take those coins and use those to establish a consensus system. So it's effectively a voting system. These coins are internal to the system, unlike computational power is with proof of work. In a sense, it's feudal, in that if you show up and you have a bunch of coins, you will continue to have a bunch of coins, and you will likely earn an ongoing reward from those coins, very much like the feudal system that a lot of us in North and South America left behind in Europe. Examples of this are Peercoin. Peercoin was actually the first one to put forward proof of stake, and it was a hybrid proof of work, proof of stake, but that's a detail. And then NXT, EOS, and Cardano all run on pure proof of stake. Hybrid proof of work, proof of stake is what we use within Decred. And what it is it's a sortition on both computational power and on the people holding the coins. It's a little bit more complex than either a pure proof of work or a pure proof of stake system, but it has some nice properties. One of these properties being that it allows you to mix the meritocratic and the feudal components of the governance system and the consensus system. So that it isn't all about, oh, I showed up with some computer hardware, or look at all these coins I have. It's a little bit of both, and it's a nice balanced middle ground. Some other examples of this hybrid system are Dash, and I already mentioned Decred. These two properties are very, they're very different. Proof of work is extrinsic, it's from the outside of the system, and proof of stake is intrinsic. These are the two simplest models you can come up with for a consensus system, and they're very, very different. Both of these models provide security in the context of attacking a consensus system. Attacking a consensus system is very different from the typical computer security attacks that people have to fend off. For example, buffer overflows, denial of service attacks, and so on. This is a totally separate type of security where we're talking about the security of the time ordering of data. So to understand what I'm talking about, I have to be more specific. What do I mean when I say attacks or consensus attacks? Do I mean dogs fighting in the street? Do I mean people fist fighting at a bus stop? These are important questions, and to understand the nature of these attacks, it's important to classify them. One way to look at these attacks is from a monetary point of view. Blockchains are necessarily scarce or create scarce assets, the coins within them, and the security of such a system can be quantified. You can say a system is a certain level of security in the sense that you say that it costs this much money to attack the system. So consensus systems are actually nice in the sense that you can actually quantify the attack. Whereas in a lot of other contexts, it's very difficult to quantify this stuff. There are really three ways to attack a consensus system. One of them is a majority attack, which is referred to as a 51% attack. And the way 51% attacks work is that you are attacking the way the system comes to consensus, the technical way that system comes to consensus. I'll say a little bit more about this in a second. And these are common attacks. They've been known for quite some time. Another class of attacks is consensus politics or consensus political attacks. And what these are is consensus depends on having a network of people that all agree and agree to a set of rules. If you can convince these people to disagree about the rules that they accept, what you're doing is you're fracturing that community and breaking it into smaller parts, which is a way of attacking that consensus system. The last class, which I won't talk about in detail, are forking bugs. Forking bugs are very tricky in the sense that you can't quantify them. If someone has written bad code or done a poor job with writing the software, forking bugs exist and they end up creating all kinds of problems. The reason I'm not going to talk about forking bugs is because it really just depends on the quality of your code. If you have good code, you're not going to have a lot of forking bugs. If you have bad code, you're going to have a lot of problems. What are majority attacks? Majority attacks connect to the original, the original conception of, the original idea of Bitcoin. And this is something that you don't hear very often anymore. In the past several years, the narrative around what Bitcoin is and what Bitcoin isn't has changed substantially. In the original white paper, proof of work is described exactly as I quote it here. And what it is it's described as one CPU, one vote, in brief. And it's really about voting. It's not about just solving hard math problems. This is a group of people with computational power voting on what chain is valid to them. And that's an important way to look at this, because you could look at a 51% attack as somebody just showing up with a bunch of computational power and causing problems. But what's really going on is that they're trying to disrupt what everyone agrees to. And how do we come to agreement? We have to vote. Understanding how majority attacks work is really important, because there's not so bad majority attacks, which are called small reorganizations, and there's very dangerous majority attacks, which you refer to as a large reorganization. When you perpetuate a majority attack against one of these cryptocurrency networks, what you're doing is going backwards in time and rewriting history. You're going backwards and going, listen, if we're at block N, I'm going to go back in time to block N-5 and create a different blockchain and get rid of the old one. This process of rewriting history, as I'm sure you can understand it, is pretty disruptive. And the way to look at a majority attack is what it is it's just, its effect is reorganizing the chain. You might have one chain and it's running along just fine. Someone with a lot of hash power comes along and go, boom, we reorganize that chain out, and then the new one takes over. Small reorganizations aren't so bad because all they do is change a few blocks at the end. So it's just a little tiny reorganization. The problem with it is censorship. I care about censorship deeply. Not everyone cares quite as much as I do. But small reorganizations are bad because they allow censorship. It's not the end of the world. No one's going to lose any money over it, though. It's, oh, I had to wait a long time for a transaction to confirm or something like that. However, large reorganizations are very bad. And the reason they're very bad is that people can really concretely lose money. If you're operating an exchange, what ends up happening is someone sends money to the exchange, they're colluding with someone running one of these majority attacks, and then boom, there's a reorganization and the funds never appeared at the exchange. This has actually been happening a fair amount recently over the past several months, where people rent hash power and perform reorganizations to cause problems at exchanges. In order to run a majority attack, you need to understand whether it's a GPU or CPU mineable currency. If a chain is mineable by CPUs or GPUs, you can actually rent those assets to attack the chain. The reason being is that CPUs and GPUs are commodity devices. Anybody can get these things. You can just show up and mash some buttons, and then next thing you know, you got a warehouse full of either normal computers or GPUs mining, and doing what you want. The larger projects that mine using CPUs and GPUs have an implicit scale-related security. If you're the biggest project and everybody's mining it using a whole bunch of CPUs or GPUs, it's very difficult for anyone to come along and pay to attack that project just by merit of scale. You have so many computers working to secure that chain that the amount that you'd need to throw at it to break it is really large. The chains that do this, Ethereum, Litecoin, and Monero, haven't had, to my knowledge, any major attacks perpetuated against them. However, if you're running a project that's pure proof of work, and you don't have these, and you have a CPU or GPU mineable chain, people can come along and reorganize your chain and cause all kinds of problems, which we've seen recently. If you have an ASIC mineable chain, it's much more difficult to attack it. And the reason is that ASICs are application-specific integrated circuits, and by merit of their being application-specific, you can't just turn on an ASIC farm and break someone's blockchain. You have to go to the people who have these and convince them, I want to rent this so that I can break something. And that's a hard sell for a lot of people who own ASICs. So how do we estimate attack costs? The cost of attack is something that's been estimated recently by, there's a site called crypto51.app, and they estimate the cost of doing these majority attacks on a number of pure proof of work cryptocurrencies. They focus on the ones that are CPU and GPU mineable. They also cover the ASIC mineable ones, but they focus on the CPU and GPU ones because that gives a sense to people how secure that chain is against attack. It's very difficult to estimate the cost of attacking a pure proof of stake chain. And the reason is that pure proof of stake requires you to actually have coins. So if you're someone who wants to attack one of these chains, you have to go buy a whole bunch of these coins, and then once you've bought the coins, you have to stake them. And that process, it's very difficult to estimate what that would cost. An example would be, if you went and you bought a whole bunch of, say, Decred, there's only so much Decred available on the open market, and you're pretty quickly going to run all that out. So you'd need to sit and carefully, quietly purchase the stuff over a very long period of time. That's difficult to pull off, and it's very expensive. You can't just, and no one's going to allow you to rent their proof of stake, because that's just not how cryptocurrencies work. Custody is everything. Estimating the cost of attacking a hybrid proof of work, proof of stake consensus system is even more complex than the proof of stake, because you have the proof of work side, which is relatively straightforward, and the proof of stake, and then you have to blend them together to create a sort of hybridized attack. And that's a challenge. We actually had somebody write an entire paper just on this topic for Decred. How do you defend against these majority attacks? Well, one of these things I've already called out is being the larger project. If you're a very large project and you have your CPU and GPU mineable, you already have a proactive large-scale investment in mining hardware. And that investment secures you against attackers. In the proof of stake context, what ends up happening is that the fact that people need to acquire the coins in the first place to run the attack, that acts as a huge insulator against the attack, because a lot of people will show up and they'll go, wow, well, how am I going to get this many coins to run this attack? And it may be prohibitively expensive, and there might not be that many on the open market. So as a result, people just don't end up running the attack. Hybrid proof of work, proof of stake ups the ante even further, where not only do you need a large-scale investment in mining, you also need to go out and buy the coins. So you have to get the hardware and the coins, and then you need to use both of those to perpetuate an attack. So the hybrid proof of work, proof of stake system acts as a strong defense against majority attacks. So we're going to change tack here a little bit and talk about the other major threat model that comes into play in the context of cryptocurrencies and consensus systems. It's running political attacks, consensus politics. And majority attacks are really expensive. If you want to run a sustained majority attack against a lot of projects, you're going to be shelling out tens, hundreds of thousands of dollars, or even millions just to run the attack. And that cues people to go, well, what if we take a different approach? What if instead of trying to go back and rewrite history because it's expensive, we instead try to attack by fracturing the community and disrupting the consensus system from that perspective? That route has been taken a number of times and in a number of different ways over the past several months and several years. And it actually bears a lot of similarity to identity politics. I can't speak for Brazil, but in the United States, identity politics is an enormously divisive issue. I'm one to believe that it's by design, and the idea is that if you can fracture a community into a large group of separate, smaller communities, it's easier to control than larger communities that have cohesive beliefs and shared values. And we see this a lot in the cryptocurrency space. So how do forks behave in the context of consensus politics? A chain can be either forked or it can be snapshotted from a particular height. I'll describe what the difference between these two is. And forking from a particular height works for most proof-of-work chains. For example, Bitcoin Cash and a number of the other Bitcoin forks were derived as continuous forks off of the Bitcoin chain. So here's the Bitcoin chain, and then boom, there's Bitcoin Cash, Bitcoin Gold, and who knows about the rest of them. That's one way to split a community based on consensus rules. That is, chain A and chain B are using different consensus rules. The other way to do this is to use a snapshot of the chain. Creating a snapshot of the chain it works as follows. You have the chain, and then the chain has a set of unspent transaction outputs. And what you can do is you can take a snapshot of that and then reset the chain, and instead of trying to fork off of an existing chain, you take the snapshot of the chain and you reset it and start from scratch. That's a little bit more extreme, and it takes more technical know-how and work, but it's very effective, and there's really no way to stop it. And it's important to recognize this because, in a way, this is almost like if anyone here is familiar with file systems, this is like taking a snapshot of a file system and then branching off from there, as opposed to keeping all of the history of an old file system. Proof of stake data center attacks are a real thing, and they're important to discuss. A lot of people, including the Decred project, don't make a huge amount of fuss about this, but I figured it was relevant in the context of what we're talking about here, which is that proof of stake validators, that is, people who participate in the proof of stake process for proof of stake consensus systems, a lot of these machines that perform this process live in data centers. So if you're at all familiar with data centers, they're the places that are really hard to get into and out of, and typically have a lot of locks and a lot of computers and air conditioning. Machines in data centers are very much vulnerable to local government compromise. If you've spent a lot of time in a data center, you know that it's very easy for people from the government to get into and out of a data center, and really hard for pretty much everyone else, typically including yourself. And this is a totally reasonable thing. I'm not saying I'm upset about it, but I'm saying we need to understand that it's a threat to consensus systems, in that governments care about this because this is a critical resource for them, and it's infrastructure that helps their nation state run. But in in the context of cryptocurrencies, it's something that can disrupt or destroy a cryptocurrency by attacking its consensus system. Delegated proof of stake systems, DPoS systems, are particularly vulnerable to attacks like this. And that includes Decred voting service providers, EOS block producers, and Tezos bakers. There's other examples, but the reason I called those out is that these are the groups that need to think about what is where in terms of the voting power in one of these proof of stake systems. The best defense you can have is to use your own physical hardware. Not everyone is capable of this. I'm a computer guy. I've been administrating my own machines for almost 20 years, and I run all of my own hardware in places that I physically control. Not everyone can do that, but if you can, that's really the best way to do it. Stability and consensus really matter because what we were just talking about with consensus political attacks is breaking up the community. So it begs the question, how can we change our consensus without splitting the community and kind of like, turning, rather than having Catholicism, there would be, say, Catholicism times 20, there's like 30 or 40 different variants. So what we're really trying to do is we're trying to keep, by analogy, Catholicism Catholic and not something else. And that matters. So if we talk about pure proof of work and consensus changes, what we end up with is that forking proof of work cryptocurrencies is actually relatively straightforward, as we've seen with the Bitcoin Cash fork. You just change the consensus rules. You go, this one was on rule set A, this one is on rule set B, and you set it going. And you can literally change nothing about the difficulty algorithm as long as you're willing to tolerate some slow blocks for a little bit. After a while, there's a retarget, and then the chain starts chugging and you're good to go. One of the problems with pure proof of work, which people have complained about a lot in the context of Bitcoin, is centralization of mining hardware. Once people start making ASICs, it's very, very militarized. It's like it's like military equipment that's constantly used against each other. So whoever has the best, airplanes or tanks wins, and they win, very, very directly. There's not a whole lot of fighting going on. And the problem with this stability, with pure proof of work, is that it's really not very stable under these consensus changes. So if people try to make consensus changes, like you go, I'm on consensus rule set A, and I want to change to B, it becomes a question of, well, what's the real chain A? Is this the real chain A where the rules didn't change, or is this the chain A where the rules did change? And these questions become, more pervasive as time goes on, and people become more switched on to how these systems work. Pure proof of stake is a little bit better, and the reason it's better is that most proof of stake systems have insulation against trivial forking. So if you have one blockchain and you want to create a fork of it with proof of stake, in most cases there are countermeasures built into the cryptocurrency that stop that or create a penalty for doing that. For example, they'll strip you of rewards, they'll strip you of the coins that you're staking. These things exist, and so there's some decent countermeasures in place. So because it's difficult to continuously fork off of most proof of stake chains, the way you would probably go about attacking it is by snapshotting it. Snapshot the chain, reset it, and then you have, chain A and chain B, as opposed to trying to create them as forks of one another. And I would argue that this has moderate stability under consensus changes because of the increased costs of running a snapshot attack. Hybrid proof of work, proof of stake is yet another incremental improvement over proof of stake. Because it has a proof of stake component, forking from a particular height does not work well. All of the systems in use that have hybrid proof of work, proof of stake make it difficult to just create trivial forks, like, chain A, chain B. If you want to fork it, you pretty much have to snapshot it and go, take a snapshot, boom, create another chain from scratch. That is, there's added complexity that comes from this hybrid proof of work, proof of stake system. And if you're going to snapshot it, you have to maintain all that stuff. Anyone familiar with Hcash? I'm not particularly fond of advertising it, but it's basically a clone of Decred. And when they cloned it, they figured out in short order, wow, this is a lot of work to maintain. And as such, they've had a very difficult time keeping up with Decred's changes. Due to the fact that both majority attacks and consensus political attacks are expensive and difficult to run on hybrid proof of work, proof of stake, I would argue that it has a stronger stability under consensus changes because of this snapshotting and maintenance. And that's really good because that means if you want to change the rules at some point, you can, and you're less likely to lose the crowd. Like, you're going to have a community, you're going to be more likely to have it be cohesive and stay as a single group, as opposed to splitting into a whole bunch of forking chains and die a death by 1,000 cuts. And just to tie this back to Decred, the way Decred works is that it's ASIC mineable, so you can't rent hash power to attack it. There's only a handful of people who produce these ASICs. A lot of them are in warehouses in China. I don't really have a problem with that. Long story short is that it's very difficult to do a majority attack on the proof of work side. Further, hybridizing proof of work and proof of stake is prohibitively expensive. Running a majority attack on it is very challenging, and it takes a lot of resources. Resources most people won't bother to spend. Just to put it in perspective, the cost of attacking Decred is on the order of its market cap. So it costs 50 to several $100 million to attack Decred in that way. And if you're going to do that, you may as well participate. Why burn the village to the ground when you can just own half the village? And per the discussion about stability under consensus changes, Decred is maximally stable under consensus changes because of its hybridization of proof of work and proof of stake. Questions? Okay. Well, thank you so much for for letting me talk for a while. I really appreciate it.